With a good set of images taken, we can transfer the image files to a folder on our computer and start the calibration. To start the calibration project, we will click the New Camera Calibration Project option on the Getting Started dialog. We navigate to the directory where we save the images from the camera and add them all to the project. We mentioned before how it was important to fill up the image with dots. Looking at the photos, we can see how the grid fills up the window. It is important to have good coverage of the frame corners. Each corner should have a mark on at least one photo. Add all the images to our project. Click Next, and the images are imported. The automated calibration dialog opens. Behind in the photo list, we see the image chips. The images have a red X indicating that they have no marks yet. Notice that we used black and white images. Color images can be used, but if your camera has a black and white monochrome setting, then this may give more accurate results. We move the dialog box into the upper corner and press Execute Calibration. It then starts the process of automatically marking the points on the grid. It will do this for each of the 12 photographs, starting at photograph 1. The report tells us it has finished marking 100 points on the grid, including 4 control points, resulting in an OK rating. The grid contains exactly 100 points, including the 4 control points. The control points are the points with the special coded targets around them. We skip ahead to the end of the automatic marking stage. We have paused the program at this point so we can review what has happened so far. The report shows how many points were marked on each photo. A good calibration will have many points marked. Some of the grid points may not appear in the photo, so we don't expect to have 100 each time. Sometimes the report will show photos with over 100 marked points, even though the grid has only 100 points. This is because the automatic marker sometimes picks up false targets in the background. If this happens, it is OK and can be ignored. Each photograph should have the 4 control points marked and the OK sign. If you do get 1 or 2 photos where only 3 control points are marked due to bad contrast, the calibration should still be fine. If many of your photos are not marked correctly, then you will need to retake them. We resume the project and we watch the progress. The focal estimation has been done at 8 mm. In this case, it has used the EXIF JPEG image data to set the focal length. Next, the marked points are automatically referenced. 93 of the 100 points are referenced. The calibration stage starts. This is where the camera parameters are calculated. We monitor the progress bar as the calibrator works. It completes the first pass of estimation camera parameters. It then does another automatic referencing stage. Now a total of 100 points are referenced. Sometimes you'll have a much lower number of referenced points in the first pass, but as long as it is greater than 20 points, it should be OK. It then does one more calibration processing, and the project is complete. The final step is checking for high deviations or correlations. If one is found, a parameter may automatically be removed, as it is not having a beneficial effect on the project. Next, we will do some verification of the calibration results by clicking Show Report. First, we look at the Problems and Suggestions area. There are no problems indicated. If your calibration does report problems or suggestions, refer to the user manual or help file. The next section gives us information about the calibration process. We check the total error. You should have an ending value of around 1 or lower. If the error is much larger, there may be an issue with your photos, such as the grid was moved between shots, or there are blurry targets. Next, we look at the Precision Standard Deviation section. This is the list of the camera parameters that were solved. The focal length shows a value of 8.17 mm. Note that it is the relative size of these parameters that is important, and not the absolute size. So if these parameters do not appear to match what you expect from the camera specifications, it could be that format size does not match the true size. That does not mean the calibration is incorrect. This is the standard deviation error, which we also call the 1 sigma error. We look for this to be a very small number. The principal point numbers indicate the center positions of the camera's imaging area. The format width is solved for. Note that the format height is not solved for, as one cannot solve for both width and height, as long as we have solved for focal length. Here we have the lens distortion parameters. All lenses distort images to some extent. Calibration is important for calculating how to compensate for this. Here we want to see that the deviation value is smaller than the parameter value itself. We check K1 and K2. K3 is only needed on extremely wide-angle lenses, and P1 and P2, and they are both good. The quality section should be studied to review how strong the calibration was. First, we will look at the point marking residuals. We expand this section. A residual is the difference between where the user marked a point and where the program expects it to be. The important number here is the maximum residual. This tells us that the maximum marking residual is 0.716 pixels, or less than 2/3 of a pixel. As a guide, the maximum residual should be under 1.5 pixels. All residuals should be under 1 pixel in a good project. The lower the number, the better. This is the overall root mean squared error of all the pixels. The value of this should be under 0.5 in a good project. We finish our review and close the camera calibration dialog. The calibration is now complete, and we have the option of adding the camera to the camera library. When importing photos for use in a project, PhotoModeler will use data in the image headers to automatically match up the images with cameras in your library. We will click Yes to add the new camera now. Cameras can be added and removed from the library at any time. Another way to check the results is by reviewing the photos and their mark. We click Select All and Open. And this opens all the photographs. We turn on residual display, and each marked point on the photograph will show a black bar starting at the mark point and going off in some direction. Where the black bar ends is where PhotoModeler thinks the mark point should be. In a well-solved project, these mark residuals will be very small. We will increase the exaggeration factor to 2000 pixels. This increases the size of the bars to help us look for patterns. A bad pattern will have all residual lines pointing in one direction, all towards the center, or all pointing away from the center. We make sure the patterns on the error bars are relatively random, and there are no patterns concentrating in small areas of the photographs that might indicate a problem. We have done a number of checks to review the calibration. First, our final error number in the processing log was around 1 or lower. Second, in the status report, we check the maximum residual. The smaller these numbers, the better, and some standard deviation numbers. And third, we check the residual errors in marking residual display to look for patterns. We can save the calibration project. This PMR file can be used to load the camera if it has not been added to your camera library. This concludes the camera calibration tutorials. In this tutorial, we have learned how to take proper photographs for use in calibration, how to calibrate a camera, how to review the calibration quality, and how to save the camera for use in our projects. A well-calibrated camera is the best way to ensure the highest accuracy for your PhotoModeler projects.